So up to now, we have developed a regression model on a selected subset of features of the house price dataset from Kaggle. Now, imagine that a new colleague from a different department comes in and says, "Hey, could you please score these new customers that arrived last month? We would like to see how accurate your model is in the most recent data that we have." So now we need to take our entire pipeline and try to transform these new datasets in order to obtain the predictions of the house's price. There are, of course, more than one way of doing it. We're going to discuss one solution in this video, and all along we're going to think about what we could have done better. We're going to import pandas, numpy, matplotlib for plotting, the scipy stats for the Eo-Jonsson transformation, and we need to import joblib to load the scalar and the lasso regression. The new data is stored in the test CSV file from Kaggle. This is the test set that does not contain the target. If you don't have this dataset yet, please refer to the lecture download datasets in section 1. We're going to drop the ID variable because this just refers to the house number and is not a predictive variable. We need to repeat the engineering steps. The first thing to do is to recast the variable as an object. Then we capture here the variables that we need to replace with missing in a list. And now here is one of the first inconveniences, right? I need to already start copying the variables manually, or hard coding as we say, into new variables. But more importantly, here I need to hard code manually for those variables that I want to replace with the most frequent category, the name of the variable, and the most frequent category that we learned when we trained the dataset. Fortunately, in the second notebook of this section, we printed those values out, but it is actually quite painful to have to hard code this manually every time we want to score new data. And more importantly, if we retrain the model, say, on a different split of train and test, these values may change. So every time we try something different, I need to manually adjust these values, which, as you can see, it takes up a lot of our time. Now we go ahead and replace the values with the string missing using fillna from pandas. And for the categorical variables that we want to replace with the frequent category, we loop over the keys of the dictionary, this one here, this is we loop over the variables, and then we replace with the value in the dictionary for each one of the particular values. For the numerical variables, we imputed missing data with the min, and again we determined the min over the training set, and we didn't store it anywhere. So now we again need to hard code those values here in order to be able to perform the imputation in the new dataset. What could we do better? Well, we could have saved this dictionary in a NumPy pickle, and then we can load this dictionary here. But that means that instead of hard coding the values here, we will have to go back to the first notebook and add lines of code in order to save each one of the individual steps. So either we add extra work as we score new data, or we need to go back to our previous notebook and add extra work there in order to save steps and mappings that we need to score new data. Again, we loop over the keys of the dictionary, so we loop over the variables, and for each one of the variables we impute with the value in the dictionary. This is what's going on in this bit of code. We also add the indicator utilizing NumPy as we did previously. For the temporal variables, we need to copy the function again. What could we do better? Maybe instead of having the function in a notebook, we could put it in a separate script, and then we can load the script with an import at the top of the notebook so that we don't have to copy code over and over. And we're going to see more of this in coming videos. And now we again loop over the variables, and then we calculate the elapsed time between the variable and the year in which the house was sold, and then we drop the year in which the house was sold. For each one of these positive variables, we apply the logarithm transformation, and for the lot area, we apply the Eo-Jonsson but we need to use the same lambda that we determined on the training set, so we need to hard code this value yet again. For the skewed variables, we perform debinarization, so if the value is 0, we keep a 0, otherwise we replace it by 1. We need to again copy all the mappings, and then copy the variables that we need to transform. What we could do better is, instead of having these mappings here, we could have them in a config file, and then load those values from the config file to save ourselves some time. The rest of the code you're familiar already. To remove rare labels, we now need to bring forward those frequent labels or frequent categories for each one of the variables. We printed them out in the second notebook, but now we need to basically hard code them here. As an alternative, instead of printing them out, we could have stored this dictionary in a pickle from NumPy. The rest of the code you know already. We replace the values of the categories that are not frequent by the string rare. Now we need to replace the categorical variables with the mappings to numeric. Again, we have this printed out in notebook number 2. We need to copy it here so that we can apply it to the new data. And with map from pandas, we apply these new mappings. We will find out that there are still some variables in the new data that contain missing values, and these variables did not present missing values in the training set. This is one of the problems that we usually encounter when we deploy models. The data that we're receiving live in our application sometimes presents missing values that were not present in our training set, so we need to decide what to do about it. In this case, just to continue with the demo, I'm going to quickly fill them up with 0. Now I load the scalar and transform my dataset. I load the features that were selected. I reduce the original dataset to the selected features. Then I load the model, and then I obtain the predictions, and here we can plot the distribution of prices. It should be fairly similar to the one that we saw in the dataset. So there are a few other things to highlight. The first one is that to score this new data, we needed to transform all the variables, even though we're only going to use some of the variables to obtain the predictions. We had to do this because the scalar that we saved here was trained on the entire dataset. So we cannot apply a scalar that is trained on the entire dataset only to a subset of features. So we have two ways about it. Either we transform all the variables and we use the same scalar, which is what we do here, or we go back to the feature engineering module and we adjust the min-max scalar only on the selected features. But as you can see, there is a lot of refurbishment that needs to be done in the code to make it suitable to score new data. So here I summarize most of the problems that we found when we tried to score new data. The first one is that we rewrote a lot of code, so this is quite repetitive and is usually not the way forward. It's too time consuming and also too boring. We hard-coded a lot of parameters. This is also very time consuming, but the most important problem here is that if we change anything in our model and we run it again on a different split of the data or with different parameters, then we may need to adjust the hard-coded bits over and over each time we run the model. We engineered then a lot of variables that we're actually not going to use in the model. This is, again, a waste of our time. And now we also observed that we have additional missing data in other variables that did not contain missing data in our training set. So this is one of the problems that we need to tackle when we deploy our machine learning model. We can minimize many of these problems if, instead of doing all the feature engineering manually as we did up to now, we did it utilizing open source packages for feature engineering. So in the next couple of videos, we will introduce open source that we can use to build machine learning pipelines and rewrite the feature engineering pipeline utilizing open source.